How did the Tacoma Narrows Bridge fall apart? Imagine a bridge that looks almost alive, twisting and swaying with the wind. Now picture it suddenly snapping and plunging into the water below. That's exactly what happened to the Tacoma Narrows Bridge. Built in 1939 and opened in July 1940, it was a marvel of engineering for its time. But it didn't last long. On November 7, 1940, a fierce wind caused the bridge to shake violently and then collapse. How did this happen? Let's find out. The key reason was a phenomenon called aeroelastic flutter. This is a kind of self-sustaining vibration that happens when wind interacts with a structure. The bridge was designed with very narrow steel girders and a lightweight deck. This made it flexible and easier to build quickly, but it also made it more vulnerable to wind. The design was different from traditional bridges that used solid trusses or stiff frameworks. Instead, this bridge had shallow girders and a long, open roadway that let wind pass through more easily. From the start, people noticed the bridge moved quite a bit in moderate winds. It earned the nickname Galloping Gertie because of its lively, bouncing motion. The problem was that the narrow girders and the long span made it prone to twisting and vertical vibrations. When the wind picked up to around 40 miles per hour, vortex shedding began. This is when swirling air vortices from behind the structure, causing it to oscillate vertically. But this wasn't the main cause of failure. It was the wind's energy feeding into the bridge's natural torsional, or twisting, vibration mode. As the wind continued, the twisting grew more intense. The oscillations became larger and more violent. The structure couldn't handle the stress. Cables and parts of the deck started to fail. The center span twisted in opposite directions on each side, creating enormous stresses. Eventually, the deck tore apart and fell into Puget Sound just for months after the bridge opened. This event changed how engineers think about wind and bridge design forever. The collapse showed that aerodynamic stability is vital for long-span bridges. After this, engineers began using wind tunnel testing to study how wind affects structures. They also started designing open trusses and vented decks that let wind pass through instead of pushing against a solid surface. These improvements help prevent similar failures today. The Tacoma Narrows Bridge's fall was a clear lesson in how flexibility and wind interaction can be a dangerous mix. It remains a landmark case in the history of bridge building, reminding us that understanding wind effects is essential in urban and infrastructure development.